Excellent. Okay, thanks for coming all the way to the end of the planet here to the session. Last session of the day. So I know what that all means. Farthest away, last session, don't have a full room. That's okay. We'll have an intimate setting here. So anyway, make sure you're in the right place. It's yet another Phone 7 session. We've had a day full of them here. So hopefully you've gotten a baseline and learned kind of a lot of the building blocks. I know you started out with an architecture session, and we've had a couple of Silverlight sessions. So hopefully what I'm trying to do is kind of build on top of some of those sessions and some of the things you've learned in that. While doing something, that's near and dear to my heart is just this pattern of occasionally connected, which isn't too hard, but it's really important for mobile devices. So I've been doing these sessions for you guys, probably for the past 5 or 6 years, and we've had a lot of different technologies over that time, and a lot of different ways to do occasionally connected. In my job, I spend most all my time working with Microsoft's largest global customers, helping them build systems to deploy to devices, tens of thousands of devices, whether it's people driving delivery trucks or people walking through corporate campuses and things like that. I've probably said this before, so if you've been to a session, I apologize. But I think half the time it's a greenfield scenario. Go to a company and they want to do something great and we build it from scratch. And the other time, usually the building is on fire is, okay, maybe it's more than half the time. And so, has everybody seen Pulp Fiction? I'm Mr. Wolf. I'm the cleaner. So, maybe not as bad as accidentally shooting some guy in the back seat of your car and having to clean it up, but that's probably most of my life. I think lots of people download white papers on how to build systems for mobile devices, and they get it running on their laptop, and they say, hey, works great. Let's deploy it for 20,000 people. And they wonder why it doesn't work out. So anyway, at least that gives me a job, right? So let's dive in here. When we go from, Windows, I've been doing this, I remember when the first iPad came out, and that was so exciting. And back then it was us against Palm, the Palm 5, Palm Pilots, and things like that. And all through that time, there's been some basic tenets about how you should build apps that are successful on mobile devices working on wireless data networks. And so as we've gone over time, some of those things have gotten easier and easier to do with things built into Windows Mobile 5 and then 6 and 6.5 and all those kind of things. And now we're moving to 7, and 7 has some new things, and it's missing some other things. And so what I want to do is try to create some continuity around things that you've been familiar with in the past by helping you, illustrate how you can do some of those same things in the future. So making them network aware, building the right kind of web services, because it's a wireless world, and wireless ain't too hot most of the time. I'm going to talk about a new kind of data sync. If you know me, I've been Mr. Sync for the last 10 years, and we seem to come out with a new kind of sync every few years, and so we're going to talk about it. Databases, you might have wondered where's SQL CE on the device. We'll talk about that, and talk about workarounds and things like that. But the big takeaway is that even without some of those things that you've known and loved over the years, I'm going to show you how you can keep on trucking and do things a lot of the same way you've done them in the past by drilling into these different areas that I think are critical. So network awareness. I remember, back in 2002 or something like that, when Handango was really popular and everybody's building apps, and that was the big app store back then, and I was building custom controls, and one of them I built was this thing that would detect the network or not, and it would run in the background, and that was a big seller. And the key takeaway there is you didn't, if your device needed to make a call to a web service or sync with a database, a remote server, you didn't want to do something that you knew was going to fail. And so, if you were in an area where you had Wi-Fi everywhere, you might be in good shape, but back then also, wireless has gotten progressively better, and it was a lot worse back then, but it's still not ubiquitous. If wireless was everywhere, we would just build mobile websites instead, but that's just not reality. As soon as I walk outside this building, who knows what's going to happen. I'm in coverage 1 minute, and then I'm out of coverage the next. And so you need to have an app that's intelligent that maybe can create a state machine for you around the state of your wireless networks. And not just that, not just is the network there or not. I mean, that's important, but also can it tell you what kind of network you have? So that, because there's a cost to doing things also. So let's say you have the network, there's still a cost. Depending on the operation you want to do, you might say, well, if I'm doing a big data sync where I want to download 10,000 rows of data to my device, I'm only going to do that over Wi-Fi. And if I detect that right now I'm just got GSM, I don't want to do that. But maybe for a lightweight web service call, maybe that's fine. You know, things like that, or uploading data. And so it's important to know all those kind of things. So when you're building apps, you know, if you have your company or for your customers, it's a critical thing, you know, to give users the best experience. And also in this world of you know, data connection charges and stuff like that, and different type data plans, these costs are important because they translate to a real cost in dollars. You know, sometimes people think that we live in a world where it's just, you know, all you can eat data no matter where you go. And, you know, that's just not reality. I've got a lot of customers that they have so many devices deployed that they have to have capped data plans, maybe as low as 2 meg a month, and maybe as slow as GPRS, in order to afford to pay for it for, let's say, 40,000 devices. They can't just give everybody an all-you-can-eat data plan. And so because of that, cost means something. So we had the state notification broker in 5, Windows Mobile 5, that came out, and then had it in 6, and we have it today. And that could tell you things about the network. Today we have some new objects in Silverlight. There's stuff that's based in Silverlight that is the same as Silverlight 3 on the desktop and the web. And then we also have some unique ones that we've got for Windows Mobile, or Windows Phone 7 rather, that can give you a little bit more information. So let's go take a look at that. So let me switch over here. Okay. So actually what I'm going to do is I'm just going to run this real quick and get this app going. All right, big surprise, yet another Contoso type application. You've probably seen a few of those. So what I've done today, instead of building a really big app with lots of screens to describe different things, I've just built one big screen scratch pad for everything I want to illustrate for you. And we're going to kind of just go from top to bottom. So the first thing we're going to talk about is you can see right now when the device came up and it's glowing green and it says Wi-Fi. And the reason for that is this device is running on an emulator on my laptop and my Wi-Fi is on and it's connected. So it detected, hey, you're green, you got a connection, and it happens to be Wi-Fi. So let's go take a look at the code that makes that happen so that you can have this work for your own applications. So let's stop that. And let's take a look at our main page here. So what we got here, you know, when we're initializing, the first thing you can see here is system.net.network information. Network address changed. So we have an event handler that you can see here that fires whenever the network address changes. So if I go from one kind of network to a different kind, or to no network at all, that event's going to fire to let me know, hey, something's changed. Let's go take a look and interrogate and see what that is so I can make a decision based on that. So the next thing you got to do is how are we going to act on that? And so what I did is I just created this little thing, network state machine. And it's right down here. Let me drag this stuff over, get you some more room. So what I do is I go into this switch case statement using network interface object and network interface type. And then we just kind of go through these case statements, you know, and we make it real easy. You know, you've got none. One is broadband CDMA, GSM, Wi-Fi, Ethernet. I know that sounds weird, but you know, a lot of people have ruggedized devices that might be in a multi-dock cradle kind of thing, and a lot of them have Ethernet, or you might have an Ethernet adapter on your device. So you could have that, you know, or you could just have no network at all, just like at the top. And so when we execute this again, this will be the first thing we hit. And sure enough, it goes down to wireless 802.11. And that's what gives us the failed to start ASP.NET server. Okay, that's not what that's there for, but that's what gave us the green light and Wi-Fi. So anyway, real simple, don't need to belabor it. This is how you do your detection. So that's kind of step one now. So let's move along here. And go back to the PowerPoint. So, RESTful web services. We've had a lot of ways to connect to remote servers over the years. Lots of proprietary ways. We've got SOAP web services that got really popular at the beginning of the last decade. Back in '99 and 2000, that became the big thing. And that was kind of the underpinnings of some of the big stuff we did with .NET. Then ASMX web services based on SOAP. And then we built WCF to be an umbrella around SOAP web services and a whole lot of other things, MSMQ, all those kind of things. And for the device, from a Windows mobile device, when we added WCF to NetCF 3.5, you could use WCF and use basic HTTP binding. And it was basically just identical to the same thing you were doing when you were calling an ASMX web service. So in Phone 7, we're going to just stick with WCF, and I'll show you why. And the great thing about WCF, especially now in WCF 4, it's gotten a lot easier to use and a lot easier to build things in. And the great thing about it is that you can build stuff that's going to work today on your servers in your data center. And then if you're ever wanting to dip your toe in the cloud with Azure, that same stuff will work exactly the same as a web role in Windows Azure. And so you don't lose anything in your investment in building some WCF web services. And then the last thing I'm going to emphasize too, at least my recommendation, is to go with using REST and JSON, because it's lightweight, and I'm all about wireless, and I know how bad wireless can be, and so it's all about efficiency. Wireless networks, even when you're on a 3G, or maybe you got the new Evo device with 4G, you know that only works in certain places, and then it falls back to slower and slower speeds, depending on where you are, or down to nothing. And in addition to that, no matter how fast the speed is, you still have latency. And so you start an operation on your device, let's say, but you notice there's this lag time where nothing's happening. And that's this big latency as your device is talking to the nearest cell tower, and then it goes down into the base station, into the backhaul network, and cruising along with 100 zillion of its best friends to get to the point to start doing something. And also you've got congestion on the tower itself. A tower can only handle so many users, and most of those towers are shared by multiple mobile operators. So latency is a big deal. So let's take a look at some REST web services. And just so you know, I'm going to spend maybe as much time, no, I'm not going to say 50% of the time on the server as the device, but it's really important, and I don't want to just talk about REST services. I want to show you how to build REST services, and I'll show you how to consume them. But before I look at any code, let's just look at my desktop here. I've got some files sitting over here, 4 of them that you can see. And what they are is, so I have a database. I've kind of built a little sample database like a supply chain thing, and I've got drivers and distribution centers and trucks and customers and products. So what I did is I have a handful of drivers, and I've tried pulling back those drivers using a variety of different wire protocols. One being SOAP, one being OData, one with REST and XML, and one with REST and JSON. And I just want to show you the difference. So at the top of the heap, weighing it at about 8.5K, as you can see here, is the OData version of pulling back all these drivers. So let's just take a look at what that looks like in Notepad here. So you see a whole lot of extra metadata here. Now, I'm not here to slam OData, because OData has some benefits too. There's trade-offs in everything. OData's, we're getting everybody on board to kind of be a device-agnostic way for lots of people to transmit data back and forth with each other. And we're even going to use it in a sync product. But I just want everybody to be aware of the cost of everything. So in order for me, so let's see if I can dig down and actually find a driver. Yes, I found one. OK. So a driver ID is 1, but we sure had to say a lot about it. A distribution center was one as well. And then here's my name, a first and last name. And so as you scroll down, you can dig in and you can find I got Lokwe here, and I've got, you know, Dan Bowie and a whole bunch of other people. So I've only got a handful of drivers here. I've got 8 drivers, but you can see it's a whole lot of data just to pull that over the wire. And it was 8.5K. So now let's take a look at SOAP and data sets. So lots of people, when we came out with .NET, you know, you built web services and you probably returned a data set because that's just the easiest thing to do. You had a data adapter and you sent it over the wire. Now I thought that was going to end up being bigger than OData, but I was surprised. So we dropped down to about 3K from 8.5K. And so let's look at the same thing here with SOAP and data set. So while you get a bunch of stuff at the top here to define things, once you go down and you see driver 1 through 8, it's not too bad. It looks just like XML with just a little bit more. So significantly smaller than OData. And that's using something that I've always thought of as the bane of my existence, is data sets. I see lots of people in the past using data sets in their apps, and they use a lot of memory. So now if we drop down from using SOAP to using REST and returning XML, we see now we drop all the way down to 1.24K. So now we're getting really small. And so let's take a look at that. So now we got rid of a whole bunch of extra metadata and schema and things like that at the top, like you saw in SOAP. And now we're just down to the basic core, you know, driver, first name, last name, distribution center ID, that kind of thing. And so it's really succinct and pulling it over the wire. So we've now really dropped down and things are getting a lot better. But wait, there's more. We can get better. If we, instead of doing REST with XML and we use JSON, look, we drop it all the way down to 639 bytes. I know these all seem pretty small, and in the world of building web services, maybe over, you know, your cable modem or a private circuit, maybe you don't care, but in the world of wireless, you should care. So now, look at JSON. Look how tiny we got. We got really small, really compact, and the big takeaway is all 4 of these things all end up doing the exact same thing in the end. You're pulling data over the wire. You basically have some objects. You basically have a database you're pulling from, and you have some objects that you're serializing. They're .NET objects on the server, and we need to serialize them into a format that we can send over the air. And then we're going to deserialize them into your application, and you're going to use them. But look how different things can be. So that's kind of what I want to get across, is just how important this is and why I think, you know, you should be a big fan of REST plus JSON. So now let's just take a closer look here. So on the left-hand side here, you can see I've got my database, Contoso bottling, and you know, all kinds of real data in here. If it decides to show it, there we go. So anyway, so real application here. Real database, and so that's where our data source is. Now let's look over the other side here, and we're going to look at our Contoso WCF service. And first thing I'll show you here is I've got this folder called models, and these models are all the object, you know, the business entities basically. Now you probably have heard of, you know, we have WCF data services and things like that, and you can do EDM and have that stuff done for you. I just did this by hand. And again, WCF data services are going to do that, you know, using entity framework, and they'll pull back OData for you. And you saw the size of OData. So anyway, I'm just doing something simple here. So here's like a kind of a customer object I built, you know, and to make these serializable from WCF and over the wire, you have to do a few things first. So the first thing you have to care about is on the top of the class, you need to decorate it with data contract. And then the other step is you've got to, for every property, you need to decorate it with data member. And these two things tell WCF and .NET to serialize this object as one of those 4 types of XML you just saw. The other thing you probably noticed, well, the other requirement to make it serializable is you need to have a constructor, you know, an empty constructor for the object. But you also probably see this strange little iNotify property change thing that I'm inheriting from. And so let's go down. You can see all the properties, blah, blah, blah. And you get down to the bottom, and you'll see this property changed event handler that fires. The reason this is here has everything to do with Silverlight and data binding, actually, and no other reason. So normally, you might do this with generics, right? And just send a generic list over, and you wouldn't have to mess around with this kind of stuff. But with Silverlight and the way we do data binding, we came up with yet another kind of object that's kind of like a generic, but it's called an observable collection. So they're all collections, but this kind of collection can fire events when properties change or things are changed and removed from your collection, your list. And so this is important to have this firing because of data binding. So once it's down on your device, in the event you choose to use data binding and data bind with a list, list box or whatever, or a grid, then it makes that aware of the changes and will update it for you automatically. So that's why we care about that. So now we know how to serialize an object and how to make it observable collection. So the next thing we need to look at is, let's take a look at the web config really quick. So here's our connection string up top here. So nothing special there, just pointing to the local SQL Express. Then you have these things like service behaviors. These are kind of boilerplate, and they don't necessarily have anything to do with REST. The one thing here, though, is critical is you add in this endpoint behavior called REST, and it's web HTTP, to distinguish it from something else like SOAP. And it's basically saying, hey, I'm just going to send back this bare minimum XML REST stuff instead of a whole bunch of other stuff. This help behavior thing is interesting. It's something we added in WCF. The one cool thing about SOAP is you had WSDLs, and you could see the contract, and people knew how to talk to it. And with REST, there is no contract. You basically have to document. If you want someone to consume your service, you kind of need to give them a piece of paper or something that says, hey, send this XML and you get this back, that kind of thing. Anyway, so we added this thing. It's not the same as WSDL, but you can get this help on your particular service, and it can give you some extra information as to what you're calling and make it helpful. The other main thing here now is here's my REST data service. And so the key thing here is, we say the configuration is REST, which is basically pointing us back up to that web HTTP part of the config. The binding is web HTTP binding. And then the contract is iREST data, and which is the next thing we're going to look at. And yeah, that's all we care about. All right, so let's go look at the contract we created. The contract is iREST data. We're just going to look at a few of these, but this is basically your interface into the real work that's going to happen. So when you did ASMX stuff, you just did it and had a method and go to town. In WCF, it likes you to build a contract first, an interface, and then implement that in another service. So that's what we do here. But we've got some nice little RESTful flavors to it. So instead of calling, one of the things, REST wants you to, be using, get, post, put against pure URLs, as opposed to like SOAP, where I would hit a single URL and maybe I could have 100 different web methods, but no distinction between any of them. So we're going to do a few things here in this contract. So let's just look here at the second one here, customers. First, I need to decorate it and say it's an operation contract. And up here, I decorated this interface and say service contract. But the next thing is I have these cool URI templates. It basically says, hey, I know I'm calling into this thing that's going to be called, restdata.svc, but I don't want to have to call into something that looks strange. I want it to look like a normal URI. And so the template here, it says for this, I'm just going to do whack customers. And that's all I'm going to have to do to get at this information. And here at the front, you see it says web get. So it's kind of a get request. So in kind of REST nomenclature, get is for kind of select, right? And pulling stuff back, Put, I'm doing inserting and post and things like that, and delete. And so that's kind of how that works. Now as we scoot along to the right here, we talk about message body style. And we say bare, in this case, as opposed to one of these other fun choices. But then the key thing here is this response format, this web message format. By default, it's going to be XML, which would return kind of what I showed you on my desktop. But luckily, you have this built-in ability to just choose JSON, and you automatically get that. So you can imagine going through all these web services methods you used to have, and instead you can use these templates and decorate them to, you know, get drivers, get orders, order details. It makes it that simple. You know, if I bring this up in a web browser, it works. You can, you know, the whole key thing about REST is you should be able to use your web browser to make any of this stuff work, which is great for testing. A good example here is I just have this little test one, and you can see the scenario where I say test, and then a question mark, and then name equals, and then, you know, in the braces there, name. So you can imagine in your web service how you would actually call that. And actually, let's see if we can fire this up just for fun and get that working just in IE. So let's view this in the browser. And ASP.NET web service thing is whacking out on me, so it may fail here. So let's take a look, because that was a weird error. So let's say here's our test. It's Joe, and there you go. So that's a quick sample of how I did a REST service, and I just said hello, and it inserted Joe into the request stream. So that's returning an XML web service that you can actually see, whereas if I was returning JSON, like if I said driver, it's going to pull something that it doesn't understand, and that's because it's JSON formatted. And you know, and as you can imagine, I saved that for you and showed it to you in a text box, a text file. So anyway, there's the quick takeaway of interfaces to get your REST going. So now let's look at we'll just look at one implementation, and then we'll move on to the device. So we'll just do for calling our customers here, or let's see, yeah, get customers. So in this case here, this might look like a lot like web methods that you've done in the past, except as you can see, I'm going to return an observable collection instead of a generic list. But it's an observable collection of objects. And you saw I had that folder with the models of all my business entities. And then, yeah, just connection string, select to get all this stuff, open up the connection. I'm going to create an observable collection of type of customer called customer list, like you might do with generics. And then as I iterate through with the data reader, I'm going to grab the data and put it into the different properties of that object. And each loop passed through, I'm going to add that to the list until it's full. And then when it's done, I'm going to return that observable collection back to the calling code, and it comes back as XML or JSON or whatever. Now again, if you use WCF data services and some other neat tools we have, all this is done automatically for you. But I just wanted you to see how to do it yourself. So that's how that all works, and that's how we get our stuff from our database. So now we can leave the server behind, and we can move along. So now you know how to build REST web services, if you didn't already. So the other half of the equation is you have to consume them. You know, before I go too far, too, the other thing, and I kind of said this in one of the slides, the slide beforehand, about open gardens and walled gardens and things like that. I'm very pragmatic about mobile. I want everybody to buy Windows Phone 7, but I know that not everybody is going to. You know, it's a free choice, and lots of people like to use other phones, and there are a lot of popular ones out there. So what I really want to make sure is if you're not going to use one of our phones, I want you to think about, though, let's bring all those other phones back to our servers. You know, we make what I just showed you pretty easy. And so if you build things with REST and JSON, well, guess what? Windows Phone 7 can consume it. Windows Mobile 6.5 can consume it. Your laptop can consume it. And so can an iPhone. And so can an Android device. And so can a BlackBerry. And so can a Nokia device running Silverlight. And so that, you know, that's kind of a pragmatic, something that makes sense. Is so exposing those device-agnostic interfaces, we see the benefit because of bandwidth. You know, we've got great servers and we've got great tools to make it easy for you. And yes, you'll support Microsoft, but at the same time, you're going to support those other platforms because, you know, the real world out there says that people have choice and they're going to do a lot of things. And different companies like to use different phones. And so that's the other big thing around REST services. It's just easy to consume. So in the past, you know, I talked about WSDL. It made it easy for NetCF and on our older devices and our current devices to consume it. I mentioned how we don't have contracts in REST, so you have to document it. Interesting thing about REST versus SOAP also is way back when in a former life, I used to be a VP at this energy trading company in Houston, and we built an exchange to trade energy commodities. And it was like building NASDAQ or something. Really amazing. I don't think I've been on anything as big and complicated and hard since, actually. And back then, before we had SOAP, web services, we posted XML fragments over HTTP. We just did XP posts. And so we built a whole API for our trading system, and anybody could connect to it and trade commodities on the system just by posting little XML fragments. And yes, we had to document it because there was no WSDL or contract because we were rolling our own. So you had a document that says, if you post this and pass these parameters, then you might expect to get this back. And that worked really well. And it was amazingly scalable and very fast. And it was running back on, if everybody remembers, Windows DNA or all the stuff when we were doing things in VB6 and C++6 and that kind of stuff, and MTS, COM+. So that worked really well, and I distinctly remember when .NET came out. And I said, hey, wouldn't it be fun to recreate this whole exchange trading system API using these cool new web services that are so easy to build? And we did it, and it was really fast to build it because you're so productive in Visual Studio. But guess what? It was a fraction of the speed. The performance went way down because it was sending so much more data over the wire. Even though we had private circuits and T3s, just because you have fast pipes doesn't mean that you can be lazy and just send more data and it's going to be just as fast, because it's not. And so a lesson was learned there that if you really want to be fast and you control both ends of the pipe, then what we were doing was right. And we were doing pseudo REST back then and didn't know it. And so now it's kind of like back to the future, I think. As everybody in the wireless space is going back to REST because of that, because it's faster, it's leaner, it's great for high latency. So I showed you how you did it, how you built it. You used URI templates and interfaces. And on the client side, you can use web client in Silverlight. You can use HTTP requests, and who knows, you can call these things from Java. You can call them from Objective-C, whatever. You're also going to use the data contract JSON serializer in Silverlight, because I told you, we decorated those objects, and they're going to be serialized as XML, and then we have to deserialize them. And so for JSON, we have to use that on the Silverlight side on the phone. So let's take a look at that. So let's just, what you can see here, I also have a models folder here with all these business entities. I apologize for not following the model view model paradigm. I'm still kind of living in MVC land, but I promise I'll get there. I guess the key thing is just making sure you keep everything separate so that you don't have any tight binding and stuff like that, and you can make changes without breaking things. So anyway, I've got some classes here, and I'm just going to show you this network access class. Real simple stuff here. And how I'm going to, and keep in mind, when you're calling these REST services or any kind of service, in Silverlight, everything has to be asynchronous, and the same goes for Phone 7. It's got to be asynchronous. So here, I'm just using web client. I create a URI, and I'm just calling the local host thing here where the ASP engine spins that up for me. And then you'll notice, just kind of like I did in the IE, I call this rest.svc and then just do whack products or whack whatever to get my data. I don't have to have some kind of cryptic looking web method. Then I do open read completed event handler, and then I open it. And then when the data comes in asynchronously, it's going to fire in here. And so I have my data contract JSON serializer to deserialize what's coming down the wire. And then I'd say, and here's what I think's coming at me. It's an observable collection of type models.product. And I, by hand, created those models on the client side for this illustration purpose. I know if you're consuming a web service or some other things, the code generator will automatically generate those business entities for you on the client side. You may not even see them, but they'll be there, so it just works. But in here, I'm illustrating it by hand. And then the next thing you see here is something I'm going to get to in a second, this data.database instant products. This is my in-memory database I created to kind of be my little replacement for SQL CE. Then I read the object as of type observable collection, and I get it. And then that's how I get the data on board. So let's take a look at that. Let's run that sucker. And boy, that really scares me when I see that thing popping up. But let's see if we get lucky. All right. So this may fail. Sometimes it fails anyway. Hey, look at that. It probably worked, for all we know. It didn't throw an error. So I clicked this button, which basically called into the method I showed you. And then let's verify to see if, in fact, it actually worked. And it did. So I clicked on products, and I see, I've got a bunch of products pulled back. I've got that products table, which is a list of different types of cola, so cherry cola, orange, that kind of thing. So you see I pulled that back. So let's take a look at that. Actually, let's move on to see, as I kind of alluded to, you saw where when that data came back, it went to this strange in-memory thing I was mentioning. So, but before I get to that, I want to tell you about asymmetric protocol. I totally spaced. I don't have any demos for this, but it's a forthcoming. I think Liam Kavanaugh on the Sync framework team has already done a session on this. I don't know if you've seen it, but moving forward, a lot of you might be saying, how am I going to do, Rob's going to show me how to do really fast web services. What if I want to do sync, where I'm exchanging deltas, like I've used with merge replication and maybe sync framework on other platforms and things like that. And the big takeaway, kind of following the same principles I taught you about, where it's device agnostic, is this asymmetric protocol. And it's using OData, and it's using the sync framework. And so right now we have sync framework 2.0. And we're going to have 2.1 coming out that's going to be fully baked for you to synchronize with SQL Azure. And I think maybe blobs and tables in Azure as well. I think I read that. But the big takeaway is they built a sync protocol where we put all the heavy lifting. Instead of you having to install the bits right on your device, like you do today with the sync framework, puts all that hard stuff back on the server. And this could be, if you're on-premise and your WCF server talking to SQL Server on-premise, or in Azure and talking to SQL Azure. So all that hard stuff goes away. And all that's left on the device is, guess what, HTTP and XML and JSON, AtomPub, things that anybody can talk to. So all your phones, all your devices, no matter what they are, they're all going to be able to consume this data and synchronize with it. And the great thing about sync, again, is we're trying to conserve bandwidth when we're going over the wire. And so we talked about conserving it with web services. What sync does well is after you do the first big ugly sync where you get all the data, from then on, you're just exchanging deltas. So just super tiny bits of data. And so when asymmetric protocol comes out, so it's going to be part of Sync Framework 3.0. So I'm not on the team. I'm not going to promise any. I think it's going to be later this year, or maybe at the beginning of next calendar year. But I think it might be later this year. I know for sure we'll have some CTPs for you to play with. But this will be a great way to do sync in this kind of same device agnostic way that I've described doing REST web services. So stay tuned for that. It's going to be pretty slick. Okay, so the in-memory database, that weird thing that I captured that data coming to me from my REST service when that asynchronous event fired. So I'm not going to assume anything. I have been, and many of my friends here in the audience have been using SQL CE for a long time as our data store, because that's kind of what you need when you build business applications or even consumer applications where you need to keep a lot of data offline. A database makes it easy to cache that data. Our SQL CE had a built-in sync right out of the box, and so it was real simple to synchronize with SQL Server and get that data, keep it offline. If the network went away, it didn't matter. You could keep working because your application, instead of always looking up and assuming, oh, I got to call something in the cloud or a web service to work, it's like, no, I'm going to look down, and I'm always working and always doing just fine talking to my local database. And then that database can synchronize in the background when my network aware thing we talked about earlier told me, hey, you can do it in the background right now because there's a network now. So I'm going to recreate it. Now, this is not some awesome database or anything by any stretch of the imagination. Think of it kind of like a four-function calculator database as opposed to a scientific calculator database. It's, but I'm just want to illustrate the point that this is something you can do, because underneath all databases they're really just objects, and they're collections of objects. That's what a table is, right? It's a collection of objects, and those objects are rows and things like that, and those properties are your columns. And so that's what a database really is underneath if you had to go build your own database from scratch. And then you just have to have it interpret things like select star from blah, 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 or insert and all the SQL syntax and interpret that and translate into object calls. So I'm not necessarily going to try to build SQL statements, but I'm going to show you how you can use a little bit of LINQ and then some normal object things to do it. And the whole thing works. I've often used a singleton to cache things that I needed for long term on my devices to keep things I want to get fast in memory. You know, in a singleton class, as you know, only one person can get at it at the same time. There's not multiple instances of it, so there's only one object, and that data in that object, you know, it doesn't get to have multiple instances of itself, so you can't get in trouble. So combining a singleton class with a place to hold all those observable collections I'm pulling from WCF kind of gives me that memory database. So let's go take a look at that. So here, I just got a class I've called database. And I'll just slowly go through here. But when you create a singleton, and again, this is just stuff right off of MSDN that's been around forever. So you make it a sealed class. It's a static read-only instance, you know, a private constructor. And then you have this entry point called instance that's also static. And so when you call into it, so when you saw that code earlier saying data, database, instance, drivers, or whatever, that's kind of your way to get into it. And so while we all know drivers is that collection, that observable collection, it's like a table. And it's like a table with a bunch of rows and columns. And so as I scroll down here in this little private database I've created, you know, I've declared variable for object collections of all these business entities. So all those things that I'm pulling from the server, and I have exact copies on my client, they're all here. And then you go down, and then as you might expect, you see the actual implementations, the public properties that let you get and set on those. And that's it. Not too big a deal. And that's how, so when all those async calls come in from your service calls, you just set these public properties of those tables equal to the resulting value coming from WCF, and you're done. And so then these guys will all be full of data, and you'll have your little database with all your tables of observable collections, which is pretty slick and pretty easy to do. And again, you know, obviously this had to be created specifically for this app, so it's not like it's some kind of generic database with cool tools to do anything. But it's just, it gives you an idea of something you can do. There's other things out there. My good friend Andy back here has done some stuff with the Purse database and did some wrappers. And I know people have written I'm not going to say full implementations of databases in C#. But if you search the web or Codeplex, I think there's a few things out here. I just wanted to let you see a kind of a simple thing here, and see that it's not a really big deal. So obviously you've got the local data store. It doesn't do you any good if you can't query it. And so, you know, I know we're missing SQL and wishing we could do that. And so, but luckily, some brilliant person created LINQ, and it sure looks like SQL to me. So our little in-memory database of objects, well, isn't that great? We have LINQ for objects. And so we're going to use LINQ to pretend it's a database, and we're going to query it. And so that's how we're going to do that. And so I'll just kind of show you just some simple little examples of pulling back the objects with some LINQ queries, and then inserts, updates, and deletes in this little demo here. So I'll just run it first, and then we'll look at the code. We'll set a breakpoint and take a look at it. But first, I really want that error thing to pop up, you know, with the ASP.NET. Okay, so I clicked the button. Means I pulled back all my data. Nothing blew up. So, you know, one of the things, it didn't really pull it back, did it? So let me click back and start it again. Because it said the products table was empty. So that's our big clue that there was nothing in there. So it didn't actually do anything. So let's try it again. Okay. So simple thing I did here with products, clicking that, you know, and I did some data binding to just show me this whole list. So if I go let's see here. I'm going to go put a breakpoint on that event handler for products. Okay. And of course, using worst practices by putting code in event handlers, but it makes it so easy for demos. But I always hate that every book and everything on the planet does it this way. So okay, I'll put an event handler, and let's do that again. Let's pull back products and stop here. And I'm going to turn on the little light here so I can see my keys. But basically, first I'm going to say, is that table, the products table, is it really there? Yes, it is. And then I'm going to say, I'm filling a list box, so I'm going to say, I want you to show name, which is one of our properties of that object. And then I'm just going to, it's just as simple as saying item source is equal to that product's in-memory database. And it data binds it to it, and that's really all there was to it. If I didn't want to do data binding, if I wanted to fill things by hand, I could do that code as well. So let's look at something a little more interesting then. So I've got delivery drivers. I pulled back a list of drivers, and we've seen all those files already. So I've got the REST drivers, and I'm just going to do a simple select. And what I did here is this select is actually selecting against the drivers who belong to distribution center 1. But I could also try out, say, well, who are the drivers in distribution center number 2? And there you have it. So wow, I guess we did a where clause, didn't we? Let's do something interesting. I'm going to do an insert, and I'm just going to insert a guy named Dave Grohl. And so let's get Dave in there. And let me refresh that. And there's Dave now. So Dave's part of our team. And let's say I want to update Dave and change him to Bill. And I'll show you the code. I really meant it to be Bill. And so you can see I'm doing these queries directly against this pseudo table and this pseudo in-memory database. And I changed the model, and it reflected in the view, didn't it? And so it just automatically updated. And then I could just, I've got Bill highlighted, and I could just say delete. And Bill's gone. So more importantly, let's take a look and see what's going on with some of this code here. Because that's what life is really all about, is code. So let's look at add driver. What did I do here? First thing is again, double check, make sure that table really exists. Then I created a new model, a new driver object, and I set its properties, its ID, distribution, first and last name. Now, if we were doing identity columns from the database, you might say, well, gosh, you don't want to have a problem with this driver ID here. And so you could always do a LINQ query and find out, the hard way, kind of like how you might do with Macs or whatever. You don't have identity columns, but I could find out what the highest number 1 is, and then I could auto increment that way. But anyway, real simple. Just created that object for a driver, and then added it to the collection, and then it appeared. The one to delete is even simpler. If you see this code right here, again, check to make sure it's not null. And then you saw I highlighted someone's name in that list box. And so I just say, yeah, whatever the selected item was, and cast it to the type of driver and just removed it from the collection. So no SQL there, just typical object type stuff. Updating, I'm sure I could do something cool with LINQ, but I didn't. So I just did a for each, and basically just looked through my little mini table, and for whatever I selected, find where it equals to, and then I change it to the name Bill. So that's kind of like how and see if I go up here, I'll show you the actual, the product select. I didn't do any LINQ, but for drivers, I created another driver, and made it my enumerable, and then just did a simple LINQ query, from a driver who lives in that table. Where distribution center is equal to, and you saw I had the little text box where I said 1 or 2, and then selected that driver, and then data bound that to the list box. And so that's how I saw the drivers in distribution that belong to distribution center 1 or 2. So you can imagine if you're building your whole supply chain management application, drivers and trucks and things belong to distribution centers, and products and where they have to go that day and deliver things like that. So you can see the value and all that kind of stuff. And this is kind of similar, what I'm actually kind of working on. A few years ago, back in 2006, I built this thing called the Mobile Line of Business Accelerator, just to help people get off the ground and accelerate their efforts in building line of business apps with Windows Mobile 5, actually, and NetCF 2.0. And it was a supply chain management, and it used merge replication with SQL Server and SQL C and things like that. And so I'm kind of just getting started of trying to do the same thing again with Phone 7. And so that's kind of the context there, or the backstory of doing this. And so you would have a much larger application with lots of screens, ordering products and delivering them and doing all kinds of things like that, and maybe using mapping control to tell a delivery driver what route to follow to get to the customers, things like that. So there is our querying for our in-memory database. So the notion that the fact that it said that's in memory tells you that that's kind of volatile, right? Just because I now have offline data cached, it doesn't necessarily mean that it's there for good. Because if you were in some other sessions, if you were in Peter Torr's session or others, you know that when you click that back button, you leave the application is suspended, it's killed, and so you've got that in-memory database, all that stuff could be goodbye, it's all gone. The same thing works with real databases. Real databases are trying to keep things in memory, and they're flushing to disk, like SQL CE by default, I think, flushes to disk every 10 seconds, and you can tweak that. So you can imagine yourself, if you were trying to build your own more full-fledged database, maybe in the background, you would be auto-flushing all those in-memory tables. And so where do you flush that to? And the answer is isolated storage. And so, we don't have SQL CE. We don't have the removable SD cards like we had before. And so, how do you do this in Silverlight? And so there's isolated storage. There's a storage file, a file stream that lets you talk to that isolated storage. And remember, this area is totally protected. Even though it doesn't have built-in encryption to encrypt the data that you're going to save, that application that's vetted by us and digitally signed in Marketplace, and then when it comes in and when you download it, it creates isolated storage just for that app, and only that app can see that data. There's no file manager. There's no RAPI connection from the desktop or any way for anybody to get at that data, and apps can't share data. So you're in pretty good shape there with your data. And ultimately, we're going to save this. We're going to serialize this. We have a couple of ways to, well, actually, I'm not going to say a couple of ways. There's probably a lot of ways to skin this cat. I'm going to show you using the XML serializer, which makes it really simple to take even complex data structures, like our big observable collections, and automatically serialize those as XML in isolated storage so you can save it and rehydrate it. But you can also use the JSON serializer we already know what's great about JSON. It's a lot smaller than XML, right? So if you use the JSON serializer, it saves data, and it saves faster, and it loads faster as well, because it's smaller. And so that's good stuff to know, too. So let's take a look at working with isolated storage with our in-memory database. So let's fire it up again. That just doesn't look fired up, does it? There we go. All right. Let's call our data. And see, we're getting sick of having to call data all the time, aren't we? Wouldn't it be great if we had some long-term offline storage here? Now let's get rid of these breakpoints. OK, so we know we got some data. We're good to go. All right, I want to save this data that I've pulled back to isolated storage. So I'm just going to click that button, and I know that I've just serialized it. We'll look at the code in a second, but I need to prove to you that this really works. So let's kill the application, and then let's fire it up again. And this time, I'm not going to click on the WCF REST data button. I'm not going to call the web services, because I've already got the data. So I'm going to hit the load database from isolated storage. And if it works, then it should deserialize the XML and pull it back into memory. Of course, you always have to freak out when the button, kind of highlights like that and just stays like that. That's kind of a bad sign. I bet you if I click anything else, it's just frozen too. So let's try this again. Actually, I know what this means. All right. Let's fire it up again. See if we get lucky. Yeah. Yada, yada, yada. All right. Please. Oh, look at that. That was much better. Dang you, emulator. All right. So, products. Ta-da! So, our in-memory database was serialized to isolated storage, and now I'm retrieving, and now I'm selecting. And see, I only saved my code here, and I'll show you the code, is I only saved the products table to memory, and I didn't save the driver, and so none of those are going to work. So let's go ahead and take a look at the code. Let me just, let's breakpoint on that, on save table. All right. So I'm just going to resave, and let's follow this guy along here. All right. So what I did is I created another class just called file access for anything I'm doing with the file system and isolated storage. And so we can just kind of walk through and see what's happening here. So first thing, again, you want to have defensive code, so making sure that that products table is not empty. And then I'm going to go ahead and use this get user store for application. So this is how I kind of get my handle onto my application's private isolated storage. And then I go along there, and I'm going to use the file stream now. You always use file streams anyway for this kind of stuff. And so in this case, I'm going to create a file called products.xml. So as you might imagine, and I know there's a lot of ways to skin this cat, and there's a lot of different ways to do it. So you can imagine how I'm doing it here. If we go back to the DBase 3 days, or FoxPro, back when databases where each table had its own file, that's just kind of the lame thing I'm doing right here too. So each table I'm saving as an XML file. So you'd have products and drivers and trucks and stuff like that. Then the next thing is I'm going to initialize the XML serializer of type observable collection using my model product, which I already have shown you. And then I'm going to serialize it and take the stream, and then I'm serializing it. I'm pointing to my singleton cache table there. And that's it. It's done, and it's saved. And then likewise, if I want to load that data, so let's follow the trail here. Well, you would think it would go there, but it didn't. Oh, because I'm looking at the wrong thing. I'm loading state, not loading table. That's why. All right. Okay. So again, grab user. Now instead of checking my in-memory database, I'm checking, hey, is that products table sitting on the disk? Is it there? And if it is, then I'm going to open that file. I'm going to deserialize it of type product and observable collection. And then I'm going to set my in-memory database thing equal to what I'm deserializing. And voila, you've got your table hydrated again. And you're good to go. So without SQL CE, and again, I'm not claiming this to be some great replacement for any database, but you can see that you can build a functioning database out of objects that will do all the things, most of the things you need to do in an application. It's not going to do left outer joins or anything crazy like that, but for most of the stuff you need to do, you'll probably be good to go with a lot of the capabilities you get with LINQ. And then you can save it long term. So now one last thing to look at while I'm talking about saving, and again, you've probably heard this in other sessions, about saving page state is a thing, because people are hitting back buttons, and so we have this different paradigm for how our applications work. And people could just hit back, and be gone. And you want to save the state, potentially, of all your different Silverlight pages, your screens. And so, while we're saving things to isolated storage, what the heck, let's do that here too. So I'm going to just show you real quick, it's name value pairs of saving page state. So actually, if I hit break on this latest emulator, I can say So the name might be job, and the value might be, delivery driver. And let's go ahead and breakpoint that, which we already got there. So I'm going to save page state. First, I'm going to be defensive and make sure that there's something in those text boxes. And if we're good to go, we'll dive into that. And this is pretty simple. And it's built-in part of isolated storage settings is app settings, because that's what it is. It can be global app settings for everything, but it also can be page by page. So when you're hitting, you heard about the pause event and things like that, or as people are backing out, that's the time that you want to be saving anything, any state of any particular screens, because a person can back out and then come flowing right back into it. If it's critical, if it's important to save it, this is exactly where you do it, so that if a person comes back to that screen, you could then rehydrate and recreate the screen and make it look exactly the way it was, just seconds before. If maybe they bounced out of there, got on the web browser, and then they want to go flying back into it. And so, real simple way. First, I'm going to check to make sure to see if it already contains that name, which is a job, and it did not. And then it's just going to add it. And so in this case, here it is, job, and the type of job is delivery driver. And then I clear that out. And then to load page state, if I just hit it, first it's going to check to see, did you do a name first? Because I can't just randomly pull stuff back. It's all about name-value pairs, right? So you really needed to enter a name in order to pull something back. So in this case, I'll put not job, but I'll put Joe, and of course it'll go through and detect that, hey, it doesn't contain that, so that's not legit either, dude. But if I do job, it should just work like a champ. It should work like a champ, right? Yes. Did I? Thanks. Oh, I got break on. That's why delete's not working. Just shoot me. Break. Okay, there's our delivery driver. Coolio. All right. And so we made it. So we've done quite a few things here. And again, my whole goal here, I'm not here to teach you basic, or core stuff, about how to do Silverlight on the phone. This is kind of like a building thing after you know how to do that stuff. And so my big goal here was just to show you how you could recreate other things that you may have done in Windows Mobile before, and how you're going to do it in the future on Phone 7. So network connectivity, we know how critical that is. Great user experience. Cost of the connection could be important if you have a capped data plan. You can't go over a certain amount. So maybe I'll do a big sync over Wi-Fi and do lightweight stuff while I'm out in the field. Maybe upload only things as I'm capturing data in the field, over GPRS or something like that. Publishing and consuming remote data. We don't have merge replication to publish data that I'm going to synchronize with, even though at some point we might have that with this new OData data sync asymmetric protocol. But showed you how to do that with REST and all the other things. And the in-memory cache database, pretty straightforward stuff. You got LINQ, and then you save it, and you're all good to go. We got all these fun resources. And of course, we have a Windows Phone contest with people with hats. But and here's all the sessions, which of course I guess it doesn't matter now. Mine's the last session of the day. And here's some for tomorrow. The mobile web thing is really interesting because the new IE7 running in the mobile can really do a great job of rendering. And also another one good tomorrow, developing mobile code today that's going to run tomorrow. Hala Siddiqui sitting right here in the front is delivering that. It's critical stuff. If you're building phone applications today on 6.5 or 5 or 6 or whatever in NetCF, and you want to know how to carry those things forward It's a critical session to check out so you can see what your roadmap is. And the good news is, all is not lost, no matter what you've heard in the papers. All right. I think we need to get to the really important part here. And it's not just me saying, please do an evaluation. But what it really is I really want to give away a phone. I want to give a phone 7 device away to one of you good folks. So I'm glad you hung around, and I really hope you fill out an evaluation. And so I'm going to ask a question, and I don't want people to blurt out the answer if they know it, and I want everybody to raise their hand if you think you know it, and I will call on you, and if you have the right answer, then you're going to get a phone 7 when it's released. So we don't have them out now, but I'm going to give this to you, and then you'll need to get with me and fill out just some of this information, because this is kind of like your coupon to get it, and then I'll get your information, and then so we can get it to you when the phone's ready to go. And so it's pretty cool stuff. So let me think really hard of a good question to ask that no one's going to know. Gosh. Okay. What was the most bloated data wire protocol? Over there in the red shirt. OData, you win. Congratulations. You got a phone. All right. Thank you so much for coming. I know it's the last session of the day, and I will answer questions. You can come up here, and I'll be happy to stick around as long. And I'm going to be here throughout the week, and so you can also come to the booth anytime, and I'll be happy to answer questions, talk to you about anything. Thank you so much for coming.
That was going to be my first question.
Yeah, yes, I'll definitely get the code posted, for sure. You got it.
How big is the isolated storage then on the phone?
It's actually, well, there's no limit. I mean, the phone may have a limit depending on the phone you bought, but we're not going to put a quota on it. So you can use as much as you want.
As far as each app can use
As far as each, yeah, it doesn't mean that you won't bump into other stuff if you start filling it up, but we're not going to put a hard limit on anything.
Is it like Silverlight and then it asks if it needs more than a certain amount?
No. Actually, it's not. It's just going to let you have as much as you want in it from the get-go. So you might be okay until you take up the whole phone, right? Yeah.
Is it a tactical thing, like the SQL C is not available on?
It's just not available now.
It's going to come?
I'm not going to make any announcements, but you've probably heard. The big gist with the phone 7 is let's get this core device out. And then after that, we'll work on getting some of the enterprise features. I know a lot of you use device management tools, System Center, and that's gone. And so the bigger plan is to start bringing back those enterprise features. And the database is part of that. But
it looks like for a line of business application, it's going down because we use a lot of support on the framework.
Yeah.
Now we need to pretty much do everything in-house, doing the data management, processing the data, and making sure the data consistency and integrity.
Sure.
Kind of taken care of by Windows.
SQL C. No, you're exactly right. And you're right. And that's kind of what I was attempting to do here was to say, hey, line of business isn't dead because we lost some of these things. You can do it here. Now, obviously, my little database doesn't have ACID support or anything like that. But yeah, I totally get where you're coming from. And so, yeah, again, I don't have anything to announce about the SQL database, but I know that there's a lot of talk about, trying to light that back up. A lot of this is about testing time. The team's working, and so it adds to the testing matrix.
The question is like how soon we need to plan to migrate our line of business application from mobile with 6.5 to in phone 7.
Well, as soon as your customers, I mean, so the phone's gonna, it's shipping, in this fall, and so,
it's not about the device availability. We are looking for the SQL support.
So I don't have any roadmap or any announcement of the SQL support, and so don't plan or make any things, any stakes in the ground about assuming that, I know that Rob said that database is coming back because it may never come back.
But it's not a strategic decision to drop the SQL support.
Yeah, it's not that we don't want it. I think it's more about timing than anything else, definitely. Yes?
A lot of sessions look like mixed sessions. Are there updates?
But my session didn't look anything like a mixed session, did it?
No. I'm talking about some of the
But some of the other ones,
Silverlight performance things
Yeah, some of those are repeats from Mix. You're right. I mean, I know they've updated their decks, but you're right. There's some familiar.
New SDK, so.
There is no new SDK. I mean, we've been doing new builds of the SDK. Well, you know, I think what we announced earlier. I know we're going to try to get the real beta. I mean, these CTPs you're downloading right now. This is still pre-beta code actually, and so that means we're still making lots of breaking changes. Trust me, I've been freaking out for the last week, or last month leading up to this, because every week I get a new build of the tools and it breaks my code over and over again. I have to keep fixing it. So, but yes, something more stable like the beta, I heard is